Alright, let's do it, ellipses. Now, in my last video, which I'm sure that you watched because people go on these binge-watching marathons of my math videos, they're just that addicting. The cliffhanger really holds people. In my last video, I was way too quiet because I was in my house at nighttime while my kids were asleep, and I was like kind of whispering to the microphone. So this video, I'm going to totally overcompensate for that to make up for it. So you're in for a treat. Hang on. You think of ellipses as ovals, or just, round things. They're more precisely thought of as a stretched circle, but it can be preciser than that. In this video, we're going to define an ellipse, graph with horizontal and vertical orientation, and find the foci, vertices, co-vertices, center, major axis, and minor axis. It's a lot of good stuff, and it's me reading really well. An ellipse is a type of conic section that has a slant that's less than the slant of the cone itself, if that makes any sense. Here, think of it this way. I've got two foci. So the plural of the word focus is focuses. It's foci. Here's 2 points, which I'll call, each of them will be a focus. Say that I was going to start at one point and walk to some other point. So I walk from focus to some point and then to another focus. Well, if I take this point x and this point y, I could add those up and that would get me a distance of some sort, equals some value. Well, let's say that I wanted to find every possible point where if I walked from one focus to that point and back to the focus, I would always walk the same distance. Those points would be spread around in an ellipse. So a good definition of an ellipse, and what I drew there just, kind of looks a little bit like a satanic club, so ignore that. A good definition of an ellipse is it's the set of all points, or the locus of points, such that the sum of distances is a constant. Walking from from a focus to a spot on the ellipse to another focus will always be the same distance walked, no matter which point on the ellipse you choose. Here's the equation for ellipses. Ellipses can have horizontal and vertical orientation. This one over here on the side has a horizontal orientation because it goes more side to side than it does up and down. Just think of it that way. It's really that simple. What determines, when you look at an equation, if you want to determine what makes an ellipse what makes an ellipse horizontal or vertical in its orientation, is what numbers are dividing the x's and the y's. So it's like, here's my x terms, here's my y terms. They're going to be divided by something a and something b, a squared and b squared. If the bigger number is underneath the x, it's going to stretch it farther left to right. If the bigger number is underneath the y, it's going to stretch it further up and down. So with ellipses, and only with ellipses, we say that a is greater than b. With hyperbolas, it doesn't matter. We haven't done hyperbolas yet. With ellipses, we say a is greater than b. So here, the bigger number is underneath y. This would be a vertical ellipse. Here, the bigger number is underneath x. This would be a horizontal ellipse. We use a, b, h, and k to find center, vertices, co-vertices, and foci. You'll see the foci uses this letter c, which I'll talk about in just a second. But a, b, h, k are going to be the stuff you're given in an equation. From that, you have to find c. So h and k do what they always do. They move the graph left to right for the h and up and down for the k. A and b stretch it horizontally and vertically. C is a point we have to calculate to find where the foci are, the individual, a focus here and a focus here. We have to calculate the value of c using what I call the evil Pythagorean Theorem. I call it evil because it has this, little minus sign here. And I picture an old-fashioned cartoon bad guy with a big mustache, and he's the evil version. It's like, there's Mario and Wario. One's just flipped. I guess Wario's supposed to be the evil one. You guys know what I'm talking about. If I were a good video creator, I'd put in a bunch of annoying little clips right now, but I'm not. So let's get going. Let's do an example. We're going to graph this ellipse and maybe put at least 5 points on it. I'm also going to find things like the center, the focus, the vertex, the co-vertex, all these things. Right now my h value is 6, my k value is -4. My a value is not 64, but it's 8. I square root this number to get the a value, and my b number is going to be the square root of 48, which is just about 7. It's really closer to 7 than it is 6.9, but we'll call it 6.9 because it's just barely under 7. So the center of this graph, which I'm going to put right here, is the point 6, -4. Because that's my center, I am going to, from there, build an x and y axis, and I might kind of fast forward through all this part. Sweet, done. Okay, this number here, this number right here, is telling me how far left and right to stretch. I know it's left and right because it came underneath the x value. That's what matters. It came underneath the x value, so I'm going to go left 8 units here, and right 8 units here. These are my vertices. Vertices are at the farthest point from the center. As you see when I actually graph the ellipse, they're going to be at the curviest point of the ellipse. So this vertex is at the point -2, -4, and this vertex is at the point 14, -4. The total distance from one vertex to the other is now 16 units. It's 2 times this, it's 16 units, and we call that the major axis. The major axis is the longest line you can draw between 2 parts of the ellipse. The graph also goes up and down this 6.9. So because this came underneath the y variable, and the y variable is the up and down variable, I'm going to go up 6.9. 1, 2, 3, 4, 5, 6. 6.9 is like right here. And 1, 2, 3, 4, 5, 6.9 is right here. And that's enough for me to try to draw out an ellipse. Now say I wanted to find one more point. Okay, let's say that I wanted to just pick one. Well, first I'll label. This is called a covertex. So this covertex is at the point 6,3. I wrote VC, but it's CV. And this is a covertex here at the point 6, -11. Almost, really -10.9. And this isn't 6,3, it's actually 6, 2.9. Those are my covertices. I'm going to find one more point on the ellipse. I'm going to plug in a number for x that will make this over here that I'm erasing right now come out relatively cleanly. I'm going to plug in 8 for x. I'm going to try and find what this exact point is right here. If I plug in 8 for x, I'll get 8 minus 6 is 2, and 2 squared is 4, and 4 over 64 can reduce. Although I wonder if there's a better one. What if I plugged in 4? That's the same thing. What if I wanted to get out of 4? What if I plugged in 10? Yeah, I'm going to plug in 10. I picked 10 because I'm just doing some mental math here. 10 minus 6 is 4, and 4 squared is 16. So this is going to become, this whole thing will become 16 over 64, which is a quarter. So I really get 1/4 plus y plus 4 squared over 48 equals 1. And I'm going to solve this for y. I've plugged in an x value and I find a y value. So I start by subtracting the quarter from both sides. And that becomes y plus 4 squared over 48 equals 3/4, because 1 minus a quarter is 3/4. This is supposed to be a 1/4 right here. It looks kind of weird. Multiply both sides by this 48, and that becomes 36. So we get y plus 4 squared equals 36. Square root both sides, and y plus 4 equals plus or minus 6. Come on, computer, keep up. Subtract the 4 from both sides. We'll get that y equals either -6 minus 4 is -10, positive 6 minus 4 is 2. So this is actually the point 10, 2, and the point 10, -10. And then because of the symmetries, I could actually bounce this over. This would be a nice clean point here, and this would be a nice clean point here at 3, 2, and 3, -10. So that's pretty great how we can move that thing around. Maybe it's actually 4. Might be off there. I think I'm good. Okay, the last thing we have to find now are the foci, the two plural of focus. I'm going to use the evil Pythagorean theorem, which is a squared minus b squared equals c squared. I know what a squared is, it's 64, and I know what b squared is, it's 48. 64 minus 48 equals 16. If 16 is my c squared, then 4 is the c. Don't worry about the plus or minus. We know we're going to move left and right 4 units. So if I get rid of this major axis that I've drawn, and here in the center, go left 4 units and right 4 units. This right here is one focus at 2, -4. This is the other focus at 10, -4. Now I've graphed vertex, covertex, foci, and some extra points also just for good measure. So the vertex is always at the curviest part, the covertex is at the least curvy part. The major axis is the longest thing you can draw, longest line you can draw between 2 points on the ellipse. The minor axis is the shortest. The major axis has a length of 16. The minor axis in this case is 13.8. That's everything you could hope to find for these ellipses. Let me show how this looks on Desmos. Here I have a circle, and the circle is centered at -2.7, comma, -3.6, just because that's where the numbers are sort of randomly. You'll notice the A and the B values are the same. This A value is 4, this B value is 4. If I increase this A value, it stretches the circle side to side without stretching it vertically. This is now a horizontally orientated ellipse. The bigger value is underneath X. But if I switch it, if I make the B value larger, now the larger number is underneath Y, and it's a vertical orientation ellipse. So these A and B values stretch the circle, whereas H and K just slide around the center. Cool. Okay, we're going to find the equation of this graphed ellipse. I need to find the center of it. I can tell pretty clearly that there's a vertex here at -6,3, and there's a vertex here at 4,3. This is another one with horizontal orientation. So the bigger number, I like to set up these, parenthesis. This is kind of the general form of how this ellipse is going to look. The bigger number is going to go here underneath X because it's stretched further left to right than it is up and down. You could find the center by doing the midpoint formula. The midpoint formula means you add up the values and average them. So -6 plus 4 is -2. Cut that in half, you get -1. So the center is at -1,3. I'm not going to call that C because C actually means the value for the focus. This is just our center. This is H, comma, K. So it's going to be X plus 1 squared, Y minus 3 squared. From the center, we're stretched 1, 2, 3, 4, 5 units. So this will be a 25. And also 1, 2 units here, so it'll be a 4. And that is the equation of the ellipse. If I wanted to find the foci, I would do a squared minus b squared equals c squared. So 21 is c squared. So whatever the square root of 21 is going to be c. That's going to be maybe like 4.5-ish, 4.4-ish. So like there's going to be a focus about here-ish, and a focus about here-ish. Okay, if this had a vertical orientation, then the bigger number would be underneath the y. So you'll notice I never actually use the formulas anywhere except for evil Pythag. That's the only formula that I use. Everything else I just think of as distances. Left and right 5, up and down 2, -1, +3 from my center. It's just distances, and then from there I draw curves. You can think of ellipses as stretched circles with horizontal or vertical orientation. An ellipse is the locus of points equidistant from two fixed points. If you start at one focus, walk to a point, and then go to another, you'll always travel the same distance. Use the evil Pythagorean theorem to find the foci at C, a squared minus b squared equals c squared. You look good today. Keep it up. Oh, sheesh, that was a long one. I don't know what this guy was thinking talking so much because it's a math video. No one wants to watch math for that long, but people do want to watch this sine wave go up and down and build what's, I guess, kind of looking like a Chinese finger trap here pretty soon. Am I allowed to call that a Chinese finger trap? Is that racist? I don't think it's racist because that's what it's actually called. If you liked this video, please like it. That's a weird sentence. And if you want to subscribe to it, that'd be helpful. Thank you. Share it with a friend. And if you're taking this class, go take your video quiz. Don't forget about that. If you're a teacher who wants to buy the curriculum that's associated with this video, check the description down below, and as always, please feel free to leave me a comment and tell me how awful I am. There it goes.